Okay, so I'm having to add two matrices. I'm having to prove this. I cannot take an example for A. I cannot do something like that. This is so annoying. 3, 4, 6, and then say I'm gonna try B is something else. There's a reason why it disappears. This is useless. 7, 2, 8, 9, right? 6, 9. I can't do this. Define two, just invent two matrices and see that it works. It would only say that it works for these two matrices. Also, I cannot just say, well, let's do it for a 2 by 2 matrix. No, you have to do it generally. So how can we do that? Because it has to be true all the time. How can I do that? Well, I can use my general form for matrices. We've seen this before. So we're wanting to write out A and B, but I'm saying we can't write down the actual numbers because we don't know them, and I don't want to use an example. So I'm going to use the general form. Any m by n matrix can be represented in that way. So A can definitely be represented like that. A11, A12, dot dot dot, A1n, and so on. B is the same. It's also an m by n because I'm able to add these two things. And I can also write it down in full form. I've been a bit quicker here. I've only written the first row and the last row, but it's basically the same thing as A, but with the B's. So A and B are two different matrices of the same size, and I don't know what the entries are, but they look like that. There are loads of scalars, right? Inside of A, there are loads of real numbers. That's what a matrix is. It's an array of real numbers. So I've got A, I've got matrix A, and matrix B. Okay, let's add them together. Let's compute A plus B using the definition of the addition of matrices. Do we have that somewhere? Sorry, I believe we do. I'm sure we do. Let's have a look. Nope. Here we are. We've seen the definition earlier. If A and B are matrices of the same size, then the sum, A plus B, is the matrix obtained by adding the entries of B to the corresponding entries of A. Okay, this is the official definition. Well, we know that really. Okay. So the definition, what it means is that I'm going to add this plus that, that's going to be my first entry. This plus that, the second one, and so on. So I've done that. So A plus B is this. First entry is first entry of A plus first entry of B. Second, and so on. A21 plus A21 plus B21, that's the 2-1 entry of the sum, and so on. This thing we know is the definition of the addition of matrices. Okay, what next? Well, all the A's and the B's, the little ones, what are they? They're real numbers. The big A and the big B, these are matrices. That's different. Actually, I know nothing of matrices. I'm trying to prove things. But I know a lot about real numbers. One thing that I know about real numbers is that adding them, I can commute them too. So the addition of real numbers commutes. Or in other words, as I'd written earlier, just forget what's here, yeah, for now. X plus y is equal to y plus x for all x and y in R. Okay, so what did I do? Oops, oh gosh. Let's go back. Come here. It gives you something to think about it. Right, we're back. Okay, so I said that A11 plus B11 is equal to B11 plus A11 because these guys are real numbers. And I know that for real numbers, it works. It's like saying here at 3 plus 4, let's say A11 plus B11 was this. And here I've said 4 plus 3. 3 plus 4. That's what I did, just switching them. I'm allowed to do that because they're real numbers, and real numbers, I know this is true. I can't do the same with matrices. I couldn't write this straight away. I couldn't start off with that at the very beginning. I couldn't do that. Well, because I don't know this. I'm trying to prove this. But I know the equivalent statement for real numbers. So I've only switched in every single entry. I've switched B for A. I've put B first, which I'm allowed to do. But look at this matrix. What is this? Well, it's all the entries of B to which I add all the entries of A. That's the very definition of B plus A. This is the definition of B plus A. Well, you can say it's completely obvious it's the same as A plus B, but no. B plus A is first the entries of B plus the entries of A afterwards, and A plus B is the opposite. So there was a step, there was something I needed to do before writing A plus B equals B plus A, and it was using the commutativity of the addition of real numbers, which I've done, and so I found out that A plus B is equal to B plus A. So it shows, that's what I was trying to do. You need to take this middle step. So, in a very similar way, you should be able to prove H. Have a look at D in your book, it's a bit harder, have a look at it. Then try and do H, and if you're struggling, or even if you're not struggling, come and show it to me, because you need to make sure you're not taking shortcuts. So have a try with H and have some fun.